Let us recap about subqueries. We typically have subqueries in from clause. We need not provide alias to the subqueries in from clause in Spark SQL. However, in earlier versions, you might have to. I have observed this in earlier versions of Hive. I'm not 100% sure with respect to earlier versions of Spark SQL. We use subqueries quite often over queries using analytics or windowing functions, especially using filtering. We will see examples as part of the next topic. This is how the syntax of a subquery will look like. You have select star from like any other query. In place of table, you can actually have circular brackets, and as part of the circular brackets, you can have a query. This will be treated as table going forward in other clauses if we specify alias. Even without specifying alias, we should be able to treat it as a table, but it can be a bit confusing. Even though it is not mandatory to specify alias, it is a good practice to specify alias for the subqueries. This is an example without alias. You can see the output here. I have used a very simple query, select current date, enclosed in circular brackets, which makes it a subquery, and you got the result. If you want to specify alias, either you can use as like this or you can remove it. It is optional. Q is the alias for our subquery. Some people tend to use as a best practice. So as per your convenience and as per standards within our projects, you can use as or you can avoid using as. Now, here is the query which will give us count by date. I just wanted to use this as an example to project the data it as a subquery. So this is how it will look like. First I have to connect to itversity retail database. Now I should be able to run this query to get the results. In this case, this will be treated as a table. You should be able to use it the way you want. Here is an example of how we can filter based upon the derived columns using subquery. In this case, order count is the derived column, which is defined as part of the subquery on top of count of one function. If you want to filter using this is how it will look like. You can just say select star from the subquery in circular brackets alias, where alias dot the column name, which is defined as part of the subquery, then the condition, which is nothing but greater than 10. In this case, we are trying to get those dates where order count is greater than 10. You should be able to run this and you can get the results. However, this is not the effective solution for the problem statement. I am just using it as an example. I am highlighting this because people might end up writing queries like this for these kind of problem statements if they randomly see this video. Just to ensure that you understand that I am using it only for example, the actual way of solving this problem is using this approach. You can just say having order count greater than 10 like this. The alias that is specified here can be used here, and you can actually run this query. In some databases, you will not be able to specify the alias that is specified as part of the set clause as part of the having clause. If that is the case, if it is throwing error, you just replace the alias with the actual function itself and it should work. With Spark SQL, even with alias will work, but in some other databases it might not work. Also, in some earlier versions, it might not work. Just to make sure that you understand, either you can specify the alias or the function call itself. I am demonstrating this as well. So this is about subqueries. Once the subquery is defined, it can be treated as table, and all the columns in the subquery can be treated as columns. We can do whatever we want with those using other clauses such as group by, having, order by, where, etc. That being said, subqueries are extensively used on top of those queries which have analytics or windowing functions. We will see how these subqueries come handy with respect to some of the use cases that are relevant to analytics or windowing functions as part of the next topic.